Okay, electric dipole. Dipole, it's a system comprising of two equal and opposite charges separated by a finite distance. So, electric dipole, suppose it is represented by plus and this minus. Both the charges should be of equal magnitude. Obviously, they are of different nature, and there should be finite separation between these two. So, this constitutes an electric dipole. So, it is basically a system comprising of two equal and opposite charges separated by finite separation. So, that is known as an electric dipole. Now, ideal dipole. What is an ideal dipole? Ideal electric dipole should have charges, equal and opposite charges of very, very large magnitude. And the separation between them should be vanishingly small. So, that's an ideal electric dipole. So, before we begin with an article, we need to learn about certain terms and definitions like dipole length, dipole moment, axial line, equatorial line. So, let's start with dipole length. It is the distance between the two equal and opposite charges which constitutes an electric dipole. So, this system is an electric dipole. The separation between these two equal and opposite charges is known as dipole length. Most important point to be noted down is that dipole length, it's a vector quantity. It possesses direction, and its direction is considered from negative charge to positive charge. It is represented as 2A. 2L, it's your wish. So, this is suppose the center of the dipole. So, this is A, this is A. So, the direction of the dipole length is along this direction from negative charge to positive charge. Obviously, its length, its SI unit is meter, but it possesses direction. Direction will be always from negative charge to positive charge. Then, electric dipole moment. It is represented by small letter p. Now, look, it is defined as product of magnitude of either of these two charges and the separation between them. Separation between them, just now we have discussed, is known as dipole length. So, it is 2A. So, this is the dipole moment. Now, look, charge is a scalar quantity. Dipole length is a vector quantity. So, dipole moment is also a vector quantity. So, dipole length, dipole moment, both are vector quantities. And direction is from negative charge to positive charge. So, this is the direction of P, from negative charge to positive charge, right? What about its SI unit? SI unit of charge is coulomb and dipole length is meter. So, the SI unit of dipole moment is coulomb meter. So, that's dipole moment. Now, regarding axial and equatorial line. This is the line along the dipole length. This is the line along the dipole length. It is known as an axial line. It is known as an axial line, right? And right perpendicular bisector of this electric dipole is known as an equatorial line. Right perpendicular bisector. So, right means right angle, 90 degrees, and it should bisect. It should bisect the dipole length. So, this line is known as the equatorial line. This is known as the equatorial line. So, our objective would be to determine the strength of electric field at a point on the axial line, and then to determine the strength of the electric field at a point on the equatorial line. So, these are the two articles which we will be discussing.